Our next keynote are the folks from SK hynix, and we'll be welcoming Jeff Jun-Young Choi, who's Vice President, Head of HBM Business Planning for the group at HK hynix, where he leads the portfolio planning and strategic direction for the next generation of high bandwidth memory, the HBM products. In this role, he's driving the successful enablement of advanced memory solutions and leads the high impact business engagement with key players across the global AI ecosystem. Jeff plays a pivotal role in orchestrating product development, customer collaboration, and business strategy into a seamless integrated process, helping Hynix position itself as the forefront of innovation in AI and high-performance computing. Prior to his current role, he led product planning for mobile and graphic DRAM, contributing significantly to SK hynix's market leadership in performance memory. Jeff holds a master's degree in electrical engineering from Korea Advanced Institute of Science and Technology and an MBA from the MIT Sloan School of Management. With him on the stage will also be Tan-Sung Kim, who is Vice President of eSSD Product Development at SK hynix, currently leads the development of the company's enterprise SSD products. He has over 15 years of experience in S.LSI development. Tan-Sung established and built SK hynix's in-house NAND flash controller teams and capabilities. He's also possessing a very well-rounded expertise in both SSD engineering and business strategy. He played a pivotal role in stabilizing SK hynix's global R&D operations and management, and he's spearheading the company's initiatives to explore the future of storage solutions in the AI era. He holds a master's degree in control and instrumentation engineering from Chungang University in South Korea. Please welcome Jeff and Tan-Sung.
Hello, everyone. I'm Jeff Choi. I know that one of these times is when your energy level requires some sleep or dip, but I will try my best. This session will not be your post-lunch sleeping pill. I will do my best. Please enjoy my presentation. Let me get started. First of all, let me introduction once again. I'm Jeff Choi, leading the HBM business planning at SK hynix. It's very honored to speak with you about the topic that lies at the heart of the AI revolution, which is memory. While AI makes headlines for the breakthroughs in compute and the model size, the truth is memory is where AI begins. Today, I want to explain you through how SK hynix redefining memory for AI, not just by making faster and large, but by building more smart, more efficient, and more integrated into the full system stack. Our journey is about performance, power, architecture, and ultimately the partnership. Let's dive in. Legal disclaimer. We will explore this journey with the three key themes. First, we will start by understanding what's really driving the evolution of AI infrastructure and what challenges it creates. Next, we will focus on the role of the memory, especially HBM, and how it must evolve supporting these demands. Finally, we will share how SK hynix is leading a new era of the full stack memory, from standards to custom solutions, and what that means for the future AI systems. The AI market is not just growing, it's evolving in complexity. Every application that we interact with, from search to image generation, is powered by tens of AI models working together, actually. These models vary in purpose, latency sensitivity, size, and compute demand. They are expanding rapidly, as you know. What's critical now is not just speed, but the ability to support the diverse and concurrent workloads. This puts immense pressure on infrastructure, especially memory. The two scale not just in the performance, but in the dimension and density, actually. All this leads to one of the biggest issues facing AI infrastructure power. From 23 to 30, power demand from the data centers is expected to rise by 3 to 6 times. And up to 65% of the power will go into the AI workloads. This means AI is not only longer the compute limited, but also is the power limited. We are entering an era where the power efficiency is as important as the compute performance. And any component that can improve performance per watt becomes central to the infrastructure today. As mentioned earlier, power consumption is skyrocketing, but the available power infrastructure simply cannot keep up. In many locations, data centers have the space to deploy new servers, but lack the power to turn them on. This is why increasingly we refer to AI as a power-limited industry. It's no longer just about how fast we can compute. It's about how smart, how efficient we can deliver that compute within the strict power constraints. To overcome this, AI systems must evolve to be denser and more power efficient and more intelligent dense. And at the heart of the AI, this evolution, specifically the HBM, which plays a critical role in a performance per watt optimization. To respond, the industry is shifting focus. We are seeing AI accelerators become more power efficient, not just for the performance, but to reduce the physical and economic footprint of the infrastructure. Improved efficiency means fewer data centers, lower TCO, and faster deployment cycle. Memory plays a key role here because the more efficient the memory, the more efficient the system. Which brings us to HBM. Historically, memory was seen as a supporting component. But in the age of AI, HBM is at the center of both performance and power optimization. Let's now explore why HBM is no longer optional and how it must evolve to remain essential in the power-limited, performance-hungry world of AI. HBM today consumes over 18% of the rack's power budget, up from the 12% just a few years ago. That means improving HBM power efficiency has system-wide impact. If we cut HBM power by 10%, we reduce the total rack power by 2%, just simple calculation. If we improve by 50%, hypothetically, that's the 10% saving, right? This equivalent of the needing one less 1 gigawatt data centers for every 10. This is the scale at which memory matters now. But it's not just about power. When customer comes to us, comes to SK hynix, whether for training or inference, they say the same thing. Bandwidth is the bottleneck. Capacity is the enabler. Together, bandwidth and capacity define how fast and how large a model can run and how responsive the AI experience feels to the end users. The pace of performance improvement in memory is far beyond that of the AI industry. That's the matter. If memory cannot keep up, performance stalls, actually, no matter how powerful the compute. This is why system architecture have changed. In the past, memory was distant after the cache from compute. Today, HBM is physically, functionally near memory, tightly coupled with the AI chips. This proximity reduces the latency and improves the throughput, while also helping manage thermal and the power envelopes. As HBM becomes power of the core system path, 3 key directions are still here, which we have to focus. First one is high capacity and high bandwidth and power efficiency. So those three key factors we have to focus for our HBM direction. So how are we doing on these three fronts? Our latest HBM products deliver 2x the bandwidth of HBM3 and improve the power efficiency by up to 40% under certain AI workloads. These are not just spec improvements. They are real system level advantage for our customers. They reduce power, increase throughput, and drive down infrastructure cost. And as publicly announced, SK hynix was the first in the world to develop HBM4, the one who shipped the samples to the major customers with the 36 gigabyte of the capacity, over 2 terabytes per second of the bandwidth, and the industry-leading efficiency. HBM4 is built to meet and exceed the demands of the next generation of AI systems. This is not just another memory product, it's the full-stack platform for the future AI infrastructure. But we know one thing, that just one standard solution, which we made, cannot serve everyone's. Different AI chips have different needs, and that diversity is growing. That's why we are now moving into a new frontier where memory is not just faster or cheaper, but the custom built to unlock the maximum value for each use case. Let me show you how. In tomorrow's architectures, memory will become even more intelligent. We may see some LPDDR memory working alongside HBM in shared workloads, or logic and compute embedded inside memory stack to accelerate specific functions. This is the next phase, where memory becomes a performance engine, not just a storage buffer. But this evolution we have discussed cannot be addressed by a single standardized approach. Each customer and each AI chip has its own architectural priorities, constraints, and optimization targets. That's why the next phase of the AI infrastructure requires a shift from the JEDEC-based standard HBM to the custom HBM. Tailored memory with the specialized features designed for each customer. This approach enables maximum performance for the specific AI chips, precision tuning for the power efficiency, and ultimately real differentiated value for the customers. By embracing the architectural diversity and the co-design memory around it, we can unlock optimization at a new level, and doing so to accelerate the entire AI industry. At SK hynix, we are committed to this path, driving both technology leadership and the customer leadership to stand at the heart of the AI's next phase. The last page, let's zoom out. Today, we live surrounded by countless AI applications, but behind those experiences lie tens of AI models running in the background. And those models are powered by the fewer than the 10 major AI chips across the industry. Yet, every one of those chips, every one, is built to work with the HBM. HBM is not just another component. It is common foundation, the bridge that makes AI chips and AI infrastructure possible. At SK hynix, we recognize this responsibility. We understand the critical role of the memory in AI, and we are fully committed to leading the evolution of AI memory going forward. AI begins with HBM, and the SK hynix stands at the beginning. This is about the SK hynix journey of HBM. Let me hand over this presentation to the CS King for another journey of SK hynix.
Thank you, Jeff. Thank you, Jeff, again, for setting this stage with HBM, which is I am very proud of. And I'm going to tell you how SK hynix is going beyond HBM. We are trying to redefine the AI future with the full stack memory and storage solutions. Let's start by looking at how AI scale is evolving. We are now entering a new era of AI. And it is no longer just about how fast your compute is. It's about how many tokens you can process and how quickly. And now we have reasoning-capable models, and that has changed many things. So token output has skyrocketed, almost 10 times in just a few months. So today's infrastructure has to keep up. It needs to move a lot more tokens, a lot faster, and that puts real pressure on memory and storage. Again, it's not about the flops only anymore. It's about tokens per second. As AI workloads continue to grow, token throughput is becoming the real bottleneck. HBM4 will surely boost overall TPS throughput, but improving the throughput and the quality of service per each user require the trade-offs. However, by optimizing the memory hierarchy, we believe we can improve both TPS throughput and quality of service. This illustration shows how we can boost AI service quality by optimizing memory hierarchy. Step one is smarter integration of next generation of DRAM and SSD more efficiently. And step two is where the real breakthrough happens. AI optimized memory and storage, pushing the performance beyond today's limit. And that's exactly what SK hynix is trying to build. Now let's take a look at how SK hynix delivers both performance and efficiency in AI optimized storage. Here is how SK hynix is building a full stack storage portfolio for AI. We continue to advance our conventional products. From PCIe Gen 5 to Gen 6, they're focusing on power efficiency and cooling technologies such as direct liquid cooling. We are also pushing the limits of capacity, moving from the 245 terabyte drives to nearline class drives reaching up to petabyte scale. And the on-device AI front, we're evolving our Zone UFS into UFS 5.0 to meet the mobile bandwidth demand. But more importantly, we are building the SK hynix will building new storage solutions optimized for AI, delivering ultra-high IOPS and high bandwidth. And this includes our own high bandwidth storage architecture for mobile and new fast NAND designed for AI, along with our own proprietary AI NAND family. I'm going to tell you a bit more detail later on. So this is our high-performance PCIe Gen 5, which is optimized for real-world AI workload. The performance numbers aside, the real impact shows up in AI agent, especially in RAG-based systems. For VectorDB workload, it delivers top-tier query performance even under multi-user scenario. And when it comes to KB cache recycling, it offers best-in-class offload reload speed, helping AI agent process tokens faster and respond quicker. This is the real-world performance, the real value for AI at scale. This is our next-generation PCIe Gen 6 eSSD, which is built for AI performance and incredible power efficiency. It pushes throughput to the limit of Gen 6 interface, saturating fully the bandwidth. Up to 2 times the power efficiency improvement compared to Gen 5. It also supports multiple form factors and scales up to 32 terabytes, making it perfect fit for AI infrastructures. And we are planning to start sampling in the end of 26. To take the SSD performance even further, we also have to break through the thermal limit. With air cooling, we're stuck around the 20 watts. And with the direct liquid cooling, we can go up to 35 watts, and even 40 watts with SK hynix's own designed thermal material. And we are also working on immersion cooling together with partners like SK Telecom. From the custom enclosures to our own thermal material, we are building SSDs ready for the next generation of high power and high performance environment. To meet AI's growing storage demand, SK hynix is breaking capacity limit with our QRC-based eSSDs. Our roadmap reaches 245 terabyte drive by early 26. This is more than just scaling, it's redefining the economics of storage. As you can see in this hierarchy, nearline SSD bridges the gap between QLC SSD and hard disk drive. It is based upon nearline flash powered by JEDEC standard. It is built to be the next generation of alternative to the nearline hard disk drive. As on-device AI grows, smartphone needs a smarter storage, not just a faster storage. John Deere Fast recognizes data placement, so allowing model weights and KV cache to be efficiently managed across the applications. Compared to conventional UFS, it delivers up to 4 times better performance and cuts the application launch time by more than half. It seems to be a simple change, but GUFS unlocks a smarter, faster AI experience on your phone. Again, SK hynix is going beyond conventional storage. To bring real AI performance to a smartphone, we need storage, memory, and compute to work as one. That is exactly what SK hynix high bandwidth storage architecture is pursuing. It starts with the UCI interface, which connects the application processor to both memory and storage. It is going to use low power wide I/O, die-to-die interface, and our own vertical fan-out package technology for efficient data movement and more bandwidth. And it is all going to be integrated into a single package, delivering unified, high bandwidth, low power, and performance for on-device AI. You can explore more details at the tech session tomorrow morning. So now let's talk about what lies beyond the SSD, which is SK hynix AI NAND family. It is a purpose-built for AI at scale. Let's walk through how AI inference actually works, from multi-user queries to output deliveries. In this pipeline, you see 2 examples of key performance bottlenecks, which are vector DB access and KV cache handling during inference decode phase. SK hynix is trying to address both with our AI NAND family. AIM performance delivers ultra-high IOPS to speed up the vector DB search. AIM bandwidth bring ultra-high throughput to deal with the growing amount of KV cache data more efficiently. Working together, they can make the entire inference pipeline more efficient and enable more scalable AI services. On the AIM performance front, vector DB search is becoming essential in the current AI inference, especially for RAG and multi-user environment. But it comes with 3 big demands: large index size, fast search speed, and consistent search qualities. These operations require high IOPS, low latencies, and fine-grained random access, often as small as 512 bytes. This is where AIMP shines. It has been designed to tackle exactly these challenges in the real-world AI workload. Our AIMP, the next generation eSSD for AI, it is under development to handle extreme IOPS demand from real-world AI workload. Powered by our new fast NAND and a purpose-built controller, the architecture can deliver up to 50 million IOPS for Gen 6 by 4 lanes, which is 7 times higher than conventional Gen 6 eSSD. The beauty of this architecture is this controller is configurable to support 100 million IOPS for Gen 6 by the end of 27. It is not just built for AI workload. AIMP also delivers high IOPS throughput for conventional storage applications as well. POC samples with E3 form factors will be ready for our strategic partner by the end of 26. On the AIM bandwidth front, if you look inside the large language model inference loop, where memory bandwidth and capacity become the true bottleneck. Inference starts with the pre-fear stage, where loading model weights and building the very first token. And then comes decoding, where tokens are repeatedly generated until the final answer is reached. This loop is pretty much memory intensive. It is getting even heavier as token volume grow up to 300 times more than before. This is why we are researching AIM bandwidth, a high throughput NAND solution for AI that works alongside HBM to keep up with this demand. Together, they can keep the entire inference loop running fast and smooth. We think AIMB can be a strong standalone solution for AI inference, but we are also exploring hybrid architectures, combining AIMB with the HBM, where SK hynix leads the industry. Our goal is to bring memory and storage closer to GPU compute and unlock the next level of AI performance. So today's AI systems still rely on conventional architectures, SSD, DRAM, HBM, working separately. But as AI scales, these components must work together more intelligently. SK hynix is now trying to expand its storage portfolio with ultra-high capacity eSSDs and AIM performance, which is designed for real-world AI workloads. And moving forward, we are exploring a new class of AI-optimized systems, integrating AIM bandwidth, HBM, and XPU in a tightly connected architectures. This is the direction we are heading, from loosely connected components to a unified AI storage and memory platform. Wrapping up, this is how SK hynix is preparing full-stack memory and storage for the future of AI. While SK hynix is known for its leadership in HBM and DRAM, today I focused on our current and future storage solutions, which is built to scale AI. I've also shared how we are exploring new architectures to help the AI ecosystem grow efficiently. I strongly recommend you to stop by SK hynix booth to experience exceptional innovation that Jeff and I talked about. Hope you enjoy FMS 2025 and discover how memory and storage are redefining what AI can become. Thank you.